Spherical coordinates part 2. Here's how we derive all these basic equations. Here's the point. Rho is the distance from the origin. Phi is the angle down from the z-axis. Drop that point down here. Theta is the polar theta. First of all, from polar coordinates, x equals r cos theta, y equals r sine theta. You can make a right triangle down here as such, and x is this coordinate, and you can derive those triangle relationships. Probably easier to see it in 2 dimensions. There's x, there's y, there's theta, there's r. It's a very simple right triangle relationship. This r, it turns out, this r you can copy up here. It's just this opposite side of a right triangle. And if you look at this, we have a right triangle, hypotenuse rho, angle phi, opposite side r. Well, what famous trig function relates the opposite to the hypotenuse? It turns out sine. So we can say sine phi is equal opposite over hypotenuse. So r equals rho sine phi. Well, guess what? If you take that and put it in here and here, you generate these 2 equations. It's just as simple as that. This equation, rho z equals rho cosine phi, well, guess what? Z is this side of the triangle, quite simply put. It's the adjacent side. What famous triangle relates the adjacent to the hypotenuse? Well, cosine, of course. Cosine is equal to z over rho. Z equals rho cosine phi. It's a simple right triangle relationship. This also, this is equation number 7. It's fairly useful when it comes to multiple integration and doing certain substitutions. That's why it's stuck there. R squared is equal to x squared plus y squared. You can square both sides. R squared is equal to rho squared sine squared phi. And from polar, r squared is x squared plus y squared. That's the Pythagorean theorem that generates this. Okay, there's a 3-dimensional Pythagorean theorem. Tan theta is y equal over x. Very simple here. Tan theta is opposite over adjacent. That's this. And this is this triangle, this relationship here just slightly altered. Cosine phi is equal to adjacent over hypotenuse, z over rho. Well, I replace rho with its rectangular equivalent, square root of x squared plus y squared plus z squared. And that's where the equations come from. Okay, fairly straightforward derivation. If you work with spherical for a while, eventually the derivations make a lot of sense. So in chapter 15, when we entertain multiple integration, we'll find this useful. We'll come back to this again. We'll also talk about cylindrical coordinates. Cylindrical is just polar with an added z. So since you have experience with polar, we're not going to spend a lot of time going through this. So, okay, that's all for this video.